Alright, let's find the determinant of the following 4x4 matrix. Alright, so in order to do that, let's see, I'm going to look for something, either row or column, that is fairly simple. Alright, I think I like the one with the 0, so I'm going to just pick, look at this guy here. I got 0 and I have a 1 there. Right, so what I'm going to do is I'm going to try to get more zeros. Right, so luckily I have a 1 here, so I can easily use that to turn 4 and 3 into 0. Right, so let's try this. Alright, so this is going to be, so I'm going to go here. Alright, I'm going to apply, I'm going to take a row, actually it's not row, it's a column 4, and multiply by -4 and add it to column 1, and that will replace column 1. So let's do that. So we're going to have, let's see, so -4 plus 4, so it's 0. 3 times -4 is -12, added to 9, so it's going to be -3. And the -4, so that's 0 as well. And that's 0, so it's going to be 3. Right? Then I got 0 now. I'm going to turn 3 into 0. So I'm going to take column 4, multiply by -3, and add it to column 2. So that's going to be our new column 2. Right? So let's do that. And -3 plus 3, 0, which is exactly what we wanted. -3, -9 plus 7, so it's -2. Alright, -3 and -1. Right? Then since I already have 0, so I'm not going to do anything to the third column, so I'll just copy the third column as it is. And then the last one, 1, 3, 1, 0. Alright? By applying these two operations, I didn't actually change the determinant, so we can focus on finding the determinant of the new matrix here. Alright, now we have a convenient row. First row is very, very convenient because only non-zero is the last one, 4. Alright, so this is going to give you, right, it's going to be negative. I'm gonna expand it along the first row. Right, so 0 times cofactor is 0, 0 times cofactor is 0, 0 times cofactor is 0. Only thing that shows up is 1 times cofactor of, maybe I should write that, 1 times cofactor of row 1 column 4. Right, which is what? So it's going to be 1 times anything, doesn't do anything. Cofactor is the same thing as -1 to the 1 plus 4 of minor 1, 4. Right? How do you find minor 1, 4? So it's going to be, so we're going to erase row 4. So, row 1. So erase that. And then column 4. So erase that. Then we look at the matrix there. So this is going to be simply, so it's going to be negative, so it's going to be -1. Right, so it's a 3x3 matrix, -3, -2, 2, 0, -3, 2, 3, -1, 4. Right, so we just need to compute that. Right, then I'm gonna still keep on using the property to make our lives a little bit easier. Alright, so first thing I would do is, again, I look at this guy. I notice that I can easily turn -3 into 0. Right, so what we can do is, I'm gonna go here. Right, I'm gonna take row 3 and add it to row 1. That will replace row 1. So that way, alright, so take row 3, multiply, we'll just add it to row 1. So 0, -1 times -2 is -3, 4 times 2, 4 plus 2 is 6, right? Everything else stays the same. So you have a 0, negative 3, 2, and the 3, negative 1, 4. Right, there's a negative sign there. Alright, then I'm going to expand along the first column. Alright, so it's going to be, there's a negative sign, so I put the negative sign there. Alright, and then let's see, so then you have 3 times, right, cofactor of let's see, row 3, column 1. Alright, so which is going to be negative 3 times negative 1 to the 3 plus 1 of minor 3, 1. Alright, so this is going to be, let's see, negative 1 to the 4th is going to be 1, so it's going to be negative 3 times minor of this guy. So we're going to erase, let's see, 3rd row and the 1st column. Alright, so that will give us negative 3, 6, negative 3, 2. Alright, since it's already 2 by 2, I'm going to go ahead and find that. So it's a negative 3 times. Negative 3 times 2 is negative 6 minus negative 3 times 6 is negative 18, so it's a plus 18. So let's see, 12 times negative 3, it's a negative 36. Right, so this is the determinant of full by full matrix. So the key is use the property, especially the row operation, to get a bunch of zeros in one row or one column to make your calculation easier. Right, that's it. I hope that this was clear.